This video is for Math 116, and so this is a continuation talking about the equation of the parabola. So I put the standard equations up here and what they tell you about which way the parabola is going to be facing and the placement of the focus and the directrix. We'll start out with a couple of these problems on page 92 because they're pretty straightforward. And so this is sort of the opposite of those problems that I did in the last video where we took the focus and the vertex and used that to determine the equation. So now we've got the equation and we want to know what are the focus and vertex and directrix. So problem 2, we've got x plus 5 squared equals 12 times y minus 3. So first off, this is the first kind of parabola. It's an upward facing parabola, which means that the focus will be above the vertex and the directrix will be below it. Okay? Alright, so our vertex is the point -5, +3. Alright, and that just comes from the values of h and k. Now, this 12 right here says that 4p is 12, so that means p must be 3. Okay? So that means the focus is going to be 3 places above the vertex at -5, 6, and the directrix is going to be the horizontal line 3 places below the vertex, or the line y equals 0. All right. That's the first one. Let's see here. What else? Well, let's do all 4 of these. 2, 4, 6, and 8 is what I'm talking about, because there's one of each. So y plus 4 all squared equals 10 times x plus 1. All right, so again, now this is a rightward facing parabola, which is we need to know because that tells us the focus is going to be to the right of the vertex, the directrix is going to be to the left. All right, so our vertex is going to be at the point -1, -4, and this 10 tells us that 4p is 10, so p is going to be 2.5. So each of those distances right there are going to be 2.5. So 2.5 places to the right of the vertex is going to be +1.5. The y-coordinate stays the same. The directrix is the vertical line. 2.5 places to the left of the vertex. X equals -3.5. Okay. Now, let's take a look at problem 6. See what we've got here. X minus 4 all squared equals -7 times y minus 6. All right, so this is an x squared problem. So it's either going to be facing up or facing down. This negative in front of a 7 tells us it's facing down. All right. The vertex is the point 4, 6. We know that 4p is equal to 7. You can put the negative in there if you want. It doesn't really make any difference. The distance is going to be 1.75. That's going to be here and here. 7/4 or 1.75. All right. And the important thing here is that the focus is going to be below the vertex. So 6 minus 1.75 should be 4.25. X-coordinate stays the same. The directrix is going to be a horizontal line 1.75 places above the vertex, and that'll be at 7, y equals 7.75. Okay. Now, problem 8 is going to be the leftward facing parabola, because that's the 4th one that we haven't seen yet. So y minus 3 all squared, -9 times x plus 4. All right? So y is squared. That means it's one of these two. that -9, that negative sign indicates it's a leftward facing parabola oriented like that. Our vertex is going to be at the point -4, +3. 4p is 9, so p is 9 over 4, or 2.25. Okay, so now our focus is going to be 2.25 places to the left of the vertex. So that's going to be -6.25. Y-coordinate stays the same. Directrix is a vertical line, 2.25 places to the right of the vertex. So that's going to take us back to, what, -1.75. Okay, all right. So there's the standard scenario. Once we have the standard equation, we can find the focus, the vertex, the focus, and the directrix based on the orientation, the value of P, and the values of H and K. All right, now we get the fun ones. So this is where we have to complete the square, put the equation in standard form, and then make these calculations. So let's look at a couple of those. Okay, problem 12, y squared plus 8y minus 4x plus 8 equals 0. Okay, so what I like to do when I'm completing a square is just clear everything else out. I'm going to move this 4x and 8 over to the other side. So now we've got y squared plus 8y equals 4x minus 8. So remember, to complete the square, we need to cut that 8 in half and then add 4 squared to both sides. Plus 16 plus 16. This will be 4x plus 8. And then the last thing I'll do here is factor out that 4. And there's our standard form. So this is a rightward facing parabola. The y is squared. The 4p is positive. So that's facing to the right. Let's see, our vertex is going to be the point where x is -2, y is -4. We know that 4p equals 4. So p is equal to 1. So that's going to be that distance there and this distance over here. All right, so let's see here. Yeah, so the focus is one place to the right of the vertex. -1, -4. The directrix is a vertical line, one place to the left, x equals -3. There we go. Okay. Now let's look at a couple more. Let's look at problem 14. X squared plus 2x minus 6y minus 11 equals 0. Okay? So again, let's clear some space here so we can complete the square. So, cut that b value in half, x plus 1 squared, then add on the 1 to complete the square. And there we go. X plus 1 all squared equals 6y plus 12. And then the last thing we're going to do, factor out that 6. And that'll help us to see the value for the vertex. So this is an upward facing parabola. And our vertex is going to be the point -1, -2. 4p is equal to 6. So p is 1.5. Let's see here. So the focus is going to be 1.5 places above this. The directrix is going to be a horizontal line 1.5 places below the vertex. And everything, I'm basing it on the y value of the vertex because it's above and below. In those rightward and leftward facing ones, I'm going to be focusing on the x coordinate of the vertex because they're going to the right and to the left. All right? I'll talk about that again when we see one of the ones where y is squared. All right, so there's problem 14. Let's look at a few more. Let's see here. 24. 6x minus y squared minus 12y plus 4 equals 0. Okay. Let's see. I'm going to move these over to the other side. If you want to complete the square, I would recommend having a positive squared term. It makes life, or that process of completing the square, much simpler. Okay, so this is going to be y plus 6 squared, which means we're going to need a 36 on either side to make that balance out. Okay, all right, now let's factor out the 6 plus 40 over 6. Let's see here. So 40 over 6, because when you multiply back through them, that'll give you 40. These are both divisible by 2. This is 20 over 3. And if you're partial to decimals, that's fine. But use a repeating decimal. This one's going to be 6 2/3, and so you could call this 6x plus 6.6 repeating. Nothing wrong with that. But you've got to have the bar to indicate that it's repeating. Okay, so this is what? Rightward facing parabola. All right, we've got a vertex here where x is negative 6.6 repeating, and y is negative 6. All right, what else? 4p equals 6, and so p is 1.5. So that means our focus here is going to be 1.5 places to the right of that negative 20/3. Let's see here. So the focus, so we've got negative 20/3 plus 3 over 2. So that's negative 40 over 6 plus 9 over 6, negative 31 over 6. Okay, and again, you can do this with decimals too if you'd like. I'll show that to you on the calculator in 1 second. Let's see, the y value is going to stay the same, and then our directrix is going to be 1.5 places to the left, and so here we just want to subtract that 9 over 6. So that's negative 49 over 6. X equals negative 49 over 6. Okay, so I did that with fractions. Let me show you a little bit on the calculator what it looks like with decimals. And the reason why I'm going to do this is because working with these calculators, no matter which calculator you've got, just don't really handle repeating decimals very well. Okay. Come on. Let's get some focus here. There we go. Okay. So we were looking at 40 divided by 6, and there it is. 6.6 repeating, that 7 at the end is not correct, okay? It's actually just an infinite number of 6s. So in any event, we wanted to take negative 6.6, so just type in a bunch of 6s, good. And then we want to add 1.5 to it. And there we go, negative 5.16 repeating. That's what I've got up there for the x coordinate of the focus. And then negative 6 and then again, just, oops, I'm hitting a 9. 6. Just hit a bunch of 6s. There we go. And then subtract the 1.5. And there we go, negative 8.16 repeating. And that's what I've got up there as 49 over 6 for the directrix. So what I'm saying, and I always say this to people, is there's nothing wrong with using decimals so long as you understand how to work with repeating decimals. Represent them correctly when you're writing them down, and if you're going to use them on the calculator, don't just type in 6.6. That's not going to give you an accurate answer. Type in as many 6s as you want, okay? I would recommend at least 7 or 8 of them, okay? And that way the calculator tends to understand that, oh, okay, we're working with a repeating decimal. All right, let's see. Let's do a couple more of these. And these numbers get a little bit tricky to calculate with, but I believe it's excellent practice to keep your skills sharp. Let's see, that was problem 24. Let's go ahead and do problem 26. Problem 26, 4x squared minus 12x plus 12y plus 7 equals 0. Okay, well, just like we saw with the circles, I would recommend dividing everything by 4. And so then we'll get x squared minus 3x plus 3y plus 1.75 equals 0. And then we'll move everything to the other side. So, x squared minus 3x equals negative 3y minus 1.75. All right, so now we need to complete the square here. Cut that value in half, 1.5, and then square this and add it to both sides, and that will allow us to complete the square. So let's see, 2.25 minus 1.75, that should be positive 1/2, right? 0.5, positive 0.5, yeah, good. Okay, so negative 3y plus 0.5. And then the last thing we have to do is factor out that negative 3. And when you factor out a negative, that's going to change this sign right here. It's going to make it negative. That should be 1/6 or 0.16 repeating. Okay? It's just like that. Only the 6 repeats. All right. And this is x minus 1.5 all squared. So this is an upside down parabola that looks something like that. So let's see, our vertex here. Oh, and if you're ever not sure what this is going to be, just take this number, divide it by what you're factoring out. Okay? The 0.5 divided by 3 is going to give you that 0.16 repeating. It's also 1/6. So our vertex, the x-coordinate is 1.5. The y-coordinate is positive 1/6. Our p-value, what? 4p is 3. And so p is 3/4 or 0.75. Okay. So our focus is going to be below, oh, I'm pointing at the x-coordinate, but it's going to be below. So that means we're interested in the y-coordinate, 1/6. All right, I'm going to get the calculator out for this one because we've got to do 1/6 minus 3/4. Oh, what is that going to be? 2 minus 9. Should be negative 7/6. Let's see here. 1/6 minus 3/4. 7/12. There we go. Yeah. Okay. So the x-coordinate stays the same. The y-coordinate negative 7/12. And again, there's nothing wrong with doing this with repeating decimals. Negative 0.583 repeating. Okay? Either one of these is correct. Neither one. It doesn't make any difference which one you do. So let's see. This horizontal line then is going to be 3/4 above this. So that's going to be 11/12. Y equals 11/12. and as a repeating decimal, that's going to be y equals 0.916 with the 6 repeating. All right, so again, the calculation gets a little messy on these, but you've got a calculator, okay? So don't be afraid to use it, and think. Think about what's happening, right? If something's above or below, then we're going to be focusing on that y coordinate. If something's to the right or to the left, then we would be looking at the x coordinate. All right, let's look at a couple of these problems where we have a graph and then have to move from the graph to an equation, a standard equation. Okay, so first thing is we want to decide which standard equation are we going to be working with. And that's going to be determined by which way the parabola is facing. So problem 30. Let's see, this one is a rightward facing parabola. We've got a vertex at -2, -3, and then another point on the curve, -8, -9. Okay, so first off, facing left means we need this one. So y plus 3 squared, -4p, x plus 2. So far, so good. All right, just plug in the values for h and k into the appropriate standard equation. Now, just like when you're, I was just doing this with Math 70, finding the equation of a line. You find the slope, plug in your x and y coordinates, you can find the y-intercept. Same thing here. Plug in these x and y coordinates, and that's going to allow us to find the value of p. Y is -9. X is -8. So, -6 squared, -4p times -6, 36 equals 24p. P is 1.5. Okay? So, 4 times 1.5 equals 6. And so our standard equation now, y plus 3 all squared, is -6 times x plus 2. So whether you carry that negative around in the value of p, or you put it outside in front of that 4p expression, that's entirely up to you. That's really just a matter of choice, okay? As a teacher, I like to put the negative sign out in front to remind people that that value will be negative, okay? I think that that's a lot more explicit than just, using this one and saying, well, p could be positive or p could be negative. And I don't think people catch on to that. Some people do, but many don't, okay? But how you go about doing it is up to you. Just so long as we come out with the correct answer here. All right, let's look at one more of these. Problem 32. Let's make some room here. All right, problem 32. We've got an upward-facing parabola with a vertex at -7, -5, and another point, -10, +4. All right, so first off, upward-facing parabola, that's what we're working with. So, x plus 7 all squared equals 4p y plus 5. All right, so there's a good start. Now, take the second point, -10, 4. Plug it in. -10 plus 7 squared, 4p, 4 plus 5. So, -3 squared, 4p times 9. 9 equals 36p. P is 1/4, 0.25. So, 4p equals 1. So this equation is going to be x plus 7 squared equals y plus 5. You can put that in parentheses and put a 1 outside there if you want to, if that makes you feel better. Nothing wrong with that, but you don't have to. Okay, so that's it for this section 2.2. In the next video, we will move on to section 2.3, and we'll look at applications, which I talked about a little bit in one of those previous videos. As always, if you have any questions, please let me know. Thanks.